All right, let's jump right in. Today, we are digging into a really fascinating and frankly pretty radical new way to build virtual worlds. It's called the Metaverse Build Runtime. And our story, believe it or not, starts with a performance puzzle so huge it seems almost impossible.
So we're going to kick things off not with some big abstract idea, but with a number. A truly massive number that tells you a system is either completely, fundamentally broken, or maybe, just maybe, it's on the verge of something really important.
400,000 times. That was the performance gap a dev team discovered between what their system could theoretically do and what it was actually doing. That's not a gap, that's a canyon.
So you have to ask, what on earth could possibly cause a slowdown of that magnitude? I mean, it sounds made up, right? But when you actually look at the numbers, the story starts to make a scary amount of sense.
Okay, so just look at this. The difference here is absolutely wild. The system had the raw potential to crunch through over 2 million operations every single second. But in reality, the pipeline was barely handling five ops per second. That's the source of that 400,000x chasm. It's insane.
So the culprits here are, well, they're pretty classic software problems, just cranked up to 11. Imagine for every single little thing you do, the system has to fire up a whole new program. Then it has to wrap up all the data, shove it through these slow digital pipes, and just wait. It was a constant digital traffic jam at every single step.
But the team didn't just give up, right? They started fighting back. First, they compiled their code, which gave them a nice little boost, but the real game changer was moving to what's called in-process C. Basically, getting rid of that whole start a new program every time nonsense. And you can see from the chart, that one change gave them a massive leap, eventually getting them to almost 70,000 operations per second. A huge, huge win. But it brings up a much bigger question.
Yeah, this is the real question, isn't it? What kind of system has a bottleneck that is so absolutely critical that you justify this level of intense, deep-level engineering to fix it? The answer is it's not a simple app. It's something much, much bigger.
Well, it's called the Metaverse Build Runtime. And no, this is not just another game engine or some social app. It's an attempt at something far more fundamental, building a true operating system for shared digital realities.
That really is the core idea. Instead of just building another pretty world on top of a shaky foundation, the goal here is to build the foundation itself. One that actually fixes the deep-seated issues that plague almost every single multiplayer and virtual platform out there today.
And you've probably run into these problems yourself, right? Authority leaks. You know, where some other player can just mess with your stuff or modify your items illegally. Implicit state, which just means it's impossible to perfectly rewind and see what really happened. And with no audit trail, there's no way to prove who owns what. In short, it's total digital chaos.
So how do you fix this chaos? The system's answer is actually built on a really powerful, simple principle. You can think of it like a constitution for a digital world, and it's built on 4 pillars. And this right here, this flow, is everything. Identity, authority, trace, projection. It is the law of the land, and it has to happen in this exact order, every single time. No exceptions.
First up, identity. Before anything else happens, the system asks one simple question. Who are you? Who's making this request?
Okay, so once we know who you are, the very next question is, are you actually allowed to do the thing you're asking to do? Do you have the authority?
And here is the absolute key. Only if that action is authorized does it get recorded as a trace. It gets etched into the permanent, unchangeable history of this world. It is now officially, lawfully part of the record.
And finally, we get to the projection. The system takes that entire history, that whole ledger of every valid thing that's ever happened, and it replays it to build the world that you and I actually see and interact with. The world we experience is just a result of that true history.
Okay, so this all sounds great in theory, right? But how does the system actually enforce this? Well, this is where we circle all the way back to that crazy performance bottleneck we started with. It's called the authority gate.
And you know, gatekeeper of reality isn't just some cool, dramatic name. It is literally what it does. It's a piece of code written in a way that makes it act like pure math. It's predictable, it's consistent, it is absolute. And every single action has to get its permission to pass. And this just lays it out perfectly. On the left, you've got the happy path. Everything checks out, a trace gets made, the world updates. Simple. But look at the right. The very moment authority is violated, the system just
halts.
And halt isn't just your typical error code. It's a promise. It's a safety contract. It means that an illegal action has absolutely zero effect on the world. It doesn't just fail. It's as if it never even happened. The reality of the world is completely shielded from it.
So when you build a system with these kinds of strict, unbreakable rules, something really interesting happens. It stops looking like normal computer code, and it starts looking a lot more like, well, something from a geometry textbook.
The designers call this a governed projection geometry. So let's break that down. You've got the total space. That's the absolute, complete truth of everything that has ever lawfully happened. Then you have the base space. That's the part you can actually see, the world you interact with. And connecting them is the fiber. That's the hidden history, the trace of events that created the world you're looking at.
And this is where it gets really cool. It means that a physical piece of hardware, like this little ESP32 chip here, doesn't need to know the entire history of the universe. It just has to be a simple window, a projection adapter that shows you a tiny piece of that truth.
And all of this leads to what might be the single most important and kind of mind-bending idea in this entire architecture.
They call it the fiber principle. And what it means is that two virtual worlds could look 100% identical on your screen, the same projection, but they could be completely different realities. They could have different histories, different rules, different owners. What you see is not the whole truth.
And so that leaves us with a pretty big question to think about, right? If the true reality of our digital worlds isn't what we see on the screen, but is instead a verifiable, auditable history of lawful events, how does that change everything? How does it change how we build these worlds, how we trust them, and ultimately, how we interact with them?